Something funky is going on here. This is not the right video. This is my first flight on the first test day. This is the only flight we have a picture from the outside. So it's kind of funny because I had a long takeoff run and I started drifting over to the side. And the guy who's taking the picture is realizing, oh, the plane is kind of coming straight towards me. But then, right then when he started to move out of the way, I took off and I also corrected and went pretty straight down the runway. I was kind of sick that day, and so I didn't do as well as I had done on the first flight, but I could tell that the controls were much improved. And then we had a couple of failures with the king post wire and servo failure, so we weren't able to get anybody else to fly. So I was really bummed out because we had 5 more pilots ready to go, and I didn't think there was any way that we would get the rest of them in there. But the next day was the perfect day for human-powered airplane flying, and it was nil wind, no wind at all. So that meant we didn't have to back the plane all the way down the runway for the next flight. So what we did is we just flew it one way up the runway, flipped it around, flew it the other way, back and forth, and we got all 5 pilots got a flight in. This is Ginger Croft, she's the first female pilot. This is taken from one of the chase bikes. The way this works is, you see those people running there, they're called the wing runners, and they hold on to a little rope on each wing until the wing lifts up enough that the pilot has control, and then they let go. Because we only have the 2 wheels in the center. We have the main gear and a small wheel in the front. So it's sort of like a U2. It doesn't have tricycle gear. And then these people are following around on bicycles. They can keep up because it flies at about bicycle riding speed. And then when she gets ready to land, they dump the bike and go grab those ropes again before the wing tips over and hits the ground. You can see how easy she's pedaling here. Everybody except one of these other 5 pilots is not a pilot. We did a little bit of sailplane training with them, and we also built our own flight simulator or a model for the flight gear simulator using the DaSH dynamics, which they said was really, really useful. So she got a little overwhelmed just with everything that was going on. She decided to stop the flight, but she could have kept going much, much longer, and she's looking forward on her next flight to go longer. And here's a flight. I'm not even going to show the whole thing because it'll take too long, but I'll show the start, and then I'll skip forward a few times. This is starting at the numbers at the north end of the Half Moon Bay runway. Skipped a couple times there before he took off. So he's a really good triathlete, and once he took off and got the hang of it, he was really good at controlling it and keeping it down the center of the runway. I'm just going to fast forward here because it looks, a lot of this looks the same. Eventually he got up a little higher. He got up maybe about 2 meters above the ground. And then he soon found himself approaching the end of the runway and deciding it was time to land. You can see here, those are the 2 guys on the bikes, and in a second they'll drop their bikes and they'll go grab the airplane. The guy on the right needs to do that pretty quickly or else the wing's going to hit. There he goes. So that was 994 meters, basically a kilometer-long flight. I have two different versions of this, but you don't need to see the other one, so let's go back to the presentation, if I can figure that out. So we're kind of out of runway on Half Moon Bay now. And the good news is that we finally, after a lot of effort, back in just November last year, we found that we probably weren't going to be able to get approval to fly at Moffett. But then Google became an acknowledged sponsor, and that helped us push it through. And just 2 days ago, we got approval to fly at Moffett. So 2 weekends from now, we're going to fly at Moffett. The runway there is 1.5 miles long, the left runway. The right runway is 1.75, but we get to use the left runway. So that's about 2.4 kilometers. So we should be able to do a flight that's over twice as long there. So now I'm going to go over the construction details. I'm going to do that by talking about some of these things first, and then I'll show some slides. I'll go kind of quickly because we're kind of getting near the end of the time here. And then we can have a little bit of Q&A. So the ribs are built by taking a hot wire, sorry about that, taking a hot wire machine that's computer controlled. You take this 2-inch wide insulation foam that you can buy at Home Depot, cut it into blocks, mount it on a hot wire machine, and I'll show you pictures of that in a minute, and then you slowly, by melting, cut out the shape. Then you take this very thin plywood, which I'll pass around, and also pass around some examples of the ribs and the we should see the plywood first. This stuff is almost like paper. You can cut it with scissors, and you laminate that onto the top, and it makes it very strong. And then you take this piece and you cut it out into a 6-millimeter wide rib on a bandsaw. Then you take these laser cut balsa pieces and put these doublers on the places where the main spar goes and where the rear spar goes. And I can pass this rib around too. Pass it on this side. Pass this. Notice those little dots on the bottom, those little white dots? That's actually a coding system so that when we cut it off, if it doesn't have the number written on, it's a digital number that we can read to know which rib it actually is and not get them mixed up. The spar itself, did we pass all those around already? Could you hand me that, one of those? I talked about this a little bit before. It's made out of carbon fiber, 2 45-degree layers. It's built up on an aluminum mandrel and then baked in this big oven, and then they pull it off of the mandrel. That spar goes into that hole, so the ribs fit over that. And then it's so thin, if you think of like an aluminum can, before you pop the top, it's really strong, but once you pop it and drink a little, it's really easy to crush on the outside. You're worried about that's called local buckling. And so to make something stronger against local buckling, without adding too much weight, we put these things on the inside. They call biscuits, the British word for cookie. It's a very lightweight white foam with some balsa wood on the outside. And there's sort of this elaborate set of tools, this long tube with strings going through it that attach to a syringe to squeeze glue out on the end, and then some prongs that hold this to push it in. And you put it into a tube like this. So this was just to practice the technique before we did it blind on the carbon fiber tubes. But it kind of shows the concept. Out here, you can see it's pretty easy to squish and deform it. When I pass this around, don't squish too hard, because this is the last one I have that hasn't been cracked on the end. But you get the idea. But in the center here, where we have the biscuits, it's very, very strong, and there's no tendency for it to want to buckle. Pass this one around this way. The way we held together all our carbon fiber tubes, this is an aluminum practice example, is, again, you saw how thin those members are. If you tried to glue that, there'd be almost no strength because there's just no bonding area. So you take a big plug of balsa wood and put it in there to give you some bonding area to tack it down. That still wouldn't have very much strength because the balsa doesn't have very much strength. Then once it's dry, it's kind of like Boy Scouts with twigs and twine. You lash the thing together, but you're using high-tech twine. You're using Kevlar tow, and then you infuse it with epoxy, and it makes a very, very strong joint that you just can't break. So I'll pass this around. This is kind of interesting. On my my first flight in February, I landed we had a crosswind and I landed with some side motion. You may recognize this is a wheel from one of those garbage containers that, everybody has, the like recycling garbage containers. It's a blow molded wheel, so it's the lightest thing we could find. It's a little rough when you're on the runway because it's got all these ridges, but it doesn't matter that much. But it's from the side motion, it wore off the wheel and made a very big lump that we then experienced but didn't know what we were experiencing for the next 2 flights. We had very, very long takeoff runs, and then we realized that we swapped it out with another wheel. This here shows, I guess I've showed you this before, this is the propeller blade. This is a 6-foot-long blade. There's 2 of them for 12-foot diameter. I'm not going to pass this around, but people are welcome to pick it up at the end. It's got a very sharp trailing edge. You can cut yourself on it, so be careful. I'll be here to supervise. And this shows you the prop shaft assembly that's attached to the front of the fuselage frame with these little stubs representing the propeller blade there. This has a few of the metal parts in it. It has some titanium and aluminum parts. There's a prop thrust bearing right in here, and then there's another bearing about halfway up there. The reason it's so long is just to get enough clearance from the nose of the fuselage fairing. And we designed it so that there's this quick release carbon fiber pin here that you can take out and swap out another set of prop blades really, really quickly. So the part that I'm holding with my hand down here is stationary, and then this part is the part that moves. It would have the chain ring attached to this spider here that I'm moving with my finger. Okay, so I'll spend a few minutes going through photos quick, and then we'll get to the Q&A. Get that, there we go. So this is our first assembly place. The first thing we did was built work tables, and we had a place that was big enough to build the entire airplane, but we lost that pretty quickly, unfortunately. To assemble the entire airplane. So this is building our first prototype prop that was an old-fashioned built-up style. That was a 10-foot diameter prop. Then we went to that one that I showed you breaking in the test. That was built by hot wiring sections out with the twist built into each section from white foam. And then prop blade I just showed you, this is a test machine with a different kind of foam and a CAD model. And then this is the actual prop, photos of different parts of it. We actually went to the trouble of machining pockets out of the thick part of it to save about 50 grams of weight. That tells you how weight sensitive we are and everything. And then it has a groove in here. It's a little bit hard to see that the engineered prop spar with the spar caps in it fits into. And then you glue it all together. You put 2 layers of this very, very thin fiberglass on it, sand it, and paint it to finish it. So this is sort of our 3 generations of prop blades lined up. This shows you this shows you the hot wire machine after it's just finished cutting through and he's pushing the centerpiece out. And then this is after we've finished this piece here. You take it on the bandsaw and cut out a piece. I've got a very short video of that. This one was done with sort of a standard fence, but eventually we got this high fence to make it easier to hold it accurately against the fence and not get a variation in the thickness of the rib. And then that rib we would take and again put the laser cut doublers on, which I think we'll have pictures of here in just a second. So these are the laser cut doublers. There's alignment marks on that rib, those little white tick marks that you use to align it, and then you use the doubler itself to actually cut the hole out for the rib. This is showing making some of the trailing edges, some test pieces. Eventually we made them in 16-foot long sections. And that fits into the groove in the back of this. Unfortunately, this is, was at Maker Faire, and so the back part broke off. Got a lot of rough treatment. Oops, sorry about that. Got a lot of rough treatment at Maker Faire. And then it's very important to put this leading edge on, otherwise you would get scalloping in between the ribs if you had Mylar on there. This is showing bending tubing for the seat. We copied a recumbent seat that used much, much lighter gauge tubing and made it about half the weight. I'm going to skip that video. So there's the finished seat. That shows the fuselage frame. We actually had to clean out the inside of the spars before we put those biscuits in because it has release film and release agent on it. This shows producing all of those biscuits. We have probably about 350 or 400 of the biscuits made this way, and then very small diameter tubes, we just use a dense version of the pink foam and have little plugs that we put in. So there's about 1,000 of these little biscuits in all of the carbon fiber tubes of the plane. This is practicing the technique. You can see here a little bit the way this works. There's these spikes on the outside of the tube that hold the biscuit, and then it's got, the whole tube is graduated so you can put it at the exact right spot. We actually put those in between the ribs of the wing because the ribs actually provide a little bit of anti-buckling from the outside, but the inside's a lot better at preventing it from getting misshaped and buckling. These are some of the parts that are inside that. This is drilling the tabs that join the two wings together. This is kind of interesting. There's two pins like this that hold the entire fuselage and human onto the wing. Just a little aluminum pin. And just this small amount of carbon or Kevlar toe is about a 5 times safety factor over the 2.5 G load limit. It doesn't look like very much to hold a whole person. And this is lining those pins up and getting them drilled in place. Then these are some shots about getting ready, the weight ready for our weight test, our load test, loading the wings up, and then doing this test. What you do is you put the right amount of water in to give your elliptical loading. We did a 1G test and then adjusted the lift wire length to get that dihedral shape, just the right shape, and then we put more water in all the bottles and it did a 1.5G test. And then we had a problem, not with our plane, but with the forklift, and the whole wing fell off and broke. The forklift had a hydraulic leak and it went like this, and then the whole thing went. We were really lucky that this pseudo fuselage we had caught on the fork, otherwise the whole thing would have done a complete 360 and completely ripped apart. The damage looks bad, but this is the wing that we actually flew, and it kind of went back like a bunch of puzzle pieces, and it only added a few hundred grams of extra balsa pieces to help support it. This is showing the covering process, and then this is showing the bending the Depron sheeting that goes on the front. Just going to zoom through these. So once you get the Mylar on, then you have to iron it. So it'll be all wrinkly at first, and then all the wrinkles kind of magically go away. I don't know if any of you have made a model airplane with Monocoat, but it's just like with Monocoat, except we have to put our own contact cement on the wood rib caps instead of having the glue already being on the monocoat like on a model. Just a few more views. We did a test assembly at Hiller Museum, the same place where we did that load test. It's really, really hard to find a building that's big enough to fit this airplane. And this is just showing some of those repairs. So we had to do a little bit of repair with doublers and stuff, but it didn't really add very much weight. All the pilots, as I mentioned, did some sailplane training because they're not actually pilots. And then this last couple pictures showing how we built the ribs to make the fuselage. There's a finished fuselage. And we also had to build a trailer, which was as big of a project as building the airplane. I found out after we designed and built most of the trailer that you can buy a 28-foot race car trailer for about half of what we spent to build our own trailer. Okay, that's it. So, questions. Thanks for holding all the questions to the end.